You've likely seen figures from the Data is Beautiful subreddit where they turn numbers into something almost artful.
The artsy dude?
But I want to compare that we can do something very similar with chemistry. Let me show you. Here is the subreddit Data is Beautiful, and this is a very large group here. And I was scrolling through and noticed a couple of bar plots that really stuck out to me. If you look here on Democrats now outnumber Republicans in the US, I don't necessarily want to focus on the politics of the story, but I do like this plot of using the stacked horizontal bar plots to tell a very visual story. Now, rather if you're left, right, or center, this is a great way to visualize this data. So I want to say whether you're caffeine or aspirin, we can also tell a very visual story using these same principles. So here I have a Python notebook, and I'm going to use Plotly Express and Matplotlib as my core libraries for making my visualization. Let me run that cell. And I'm going to look at the elemental composition of glucose, aspirin, and caffeine. Glucose, which is mostly carbon and oxygen by mass. Aspirin, which is mostly carbon and some oxygen. And then caffeine, where we also now have nitrogen introduced to the chemical composition. I'm going to create a list of compounds, glucose, aspirin, and caffeine. Next, I'm going to compute their percent mass composition of the major elements. And then I'm going to also reverse the order so that the order in the figure matches this compound list. I'll show you what happens if we don't do that. And let's begin plotting. To plot, we're going to use the plot.subplots method. We're going to set our fig size to 10 by 6. And we're going to create multiple different bars. The first bar is our carbon, followed by hydrogen, oxygen, and nitrogen. And we're going to use this argument called left, which is very important for stacking our bar plot. In the first bar for carbon, we don't need this argument, but as we stack hydrogen, oxygen, and nitrogen, we now have our left argument populated. For hydrogen, we only need to consider the mass of carbon. For oxygen, we need to include carbon and hydrogen. And for nitrogen, we need to include all the previous elements. And then we're just going to add a title and a legend to this figure, and then we're going to render it. When we do this, you can see we have generated something very similar to what was plotted before. I'm using a slightly different color map, but we really could have created the original color map as well. You can see here we have glucose, where blue is carbon, red is hydrogen, and green is oxygen. And then for the caffeine, we introduce our nitrogen color in purple. Now, the left argument here is very critical, so let me replace the left for hydrogen to 0 instead of carbon. When I do that, you see our hydrogen bar has moved over to the left side, starting at x equals 0, instead of slotting here in this area here. So this is how we're able to generate those bars. Let me replace this with carbon. And then let me show you what happens if we don't reverse our list. So we have our list of compounds as glucose, aspirin, and caffeine. And in this case, the order may not matter exactly, but let's say we do care about the order. If we run this again, you see that now caffeine is first, aspirin is second, and glucose is last. So we end up having our list here reversed, where glucose we want to be first. And this could really matter depending if you're trying to build into a certain direction. So I'm going to remove this comment, and we can generate our original bar plot just like this. If there are other figures you like, let me know below and I will create them on the channel as well. And if you want other inspiration, feel free to visit the Data is Beautiful subreddit. You're likely to find a figure that you can use in your own domain and generate that figure using Python. If you liked this video, visit this other Data is Beautiful video right here. In any case, I'll see you in the next video. Peace.